right, last section before we work the practice problems, which I probably will also do. But, okay, so we're gonna take the last little section here, and this has to do with how enthalpy, delta H, which we talked about last week, and delta S, or entropy, how those two concepts relate. And it turns out that they relate to each other in something that we call Gibbs free energy, okay? Now, Gibbs free energy is this equation right up here. And Gibbs free energy tells us the change in energy, Gibbs free energy, is calculated by looking at the change in enthalpy, the change in energy, and subtracting from that the temperature, the absolute temperature. So our temperature in this module, again, has to be in Kelvin. Our temperature multiplied by the entropy of that system, okay? Now, why do we care? Well, it turns out that this equation allows us to determine whether a reaction is spontaneous or not, okay? Now, a spontaneous reaction is one that occurs in a given set of conditions without interventions. So if a reaction is spontaneous, a spontaneous reaction is one that occurs in a given set of conditions without intervention. Now, one thing I want to make sure that you explain, when we talk about a reaction being spontaneous, we are not meaning it happens without energy, that it has no activation energy, that it just happens around you, right? So it's not like we sometimes hear something about spontaneous combustion, something just igniting. We're not talking about that, about a reaction happening without any energy being added into the chemical reaction. What we're saying is that it can occur without there being intervention, and that kind of means it can happen naturally. So a really good example of a spontaneous reaction or a spontaneous process would be each of your bedrooms. So right, when you clean your bedroom up, does it stay neat and perfectly clean forever? No, because without any intervention, right, what happens is that we move from more order to less order, right? So that whole messiness that happens in your rooms, that is a good example of a spontaneous process. One that happens without anything being needed, in a condition without needing to intervene and require that to happen. So that's what spontaneity means in this particular situation. So when we look at this, if we have a delta G that is less than 0, meaning it's negative, then we are going to have a spontaneous reaction, okay? So, where's my little thing here? Okay, so if we apply this equation for delta G to an exothermic reaction, okay, let's think about that for a minute. If we have a negative number for delta S, and we're subtracting, right, some other number, because this is always going to be temperature's positive, delta H can be positive or negative, right? But if we have this being a negative number and we subtract from that some other number, right, that's the same as adding a negative, right? So we end up with an exothermic reaction. We're always going to end up with a delta G that is less than 0. But that's not true for every single reaction. We can have some reactions where the delta H is actually less than this T times the entropy. So if this delta G is a positive number, then what that means is that it's not spontaneous. Now that doesn't mean we can't change the conditions, right, so that it can be spontaneous. It just means, right, so it doesn't mean it can't ever happen. It just means at the given set of conditions, meaning the certain temperature, right, the conditions at which you're running it, that it's not spontaneous, meaning it's going to require, it has more disorder on the front end, moving to less disorder on the back end. And that's not consistent with the second law of thermodynamics, okay? So again, we can also calculate, we have two ways to calculate it. We can calculate it with this, if we know entropy and change in enthalpy. So if we know change in energy and we know our disorder, we can calculate our delta G. We can also use this equation here, which basically, again, We go to the tables, we look up delta G of formation of the products, we sum all those up, we subtract from that the delta G of the reactants, right? And that will give us our delta G. And again, we're looking for our delta G to be negative. Okay, so now I'm going to come on back, I'm going to take a little pause, and I'm going to work through some of the practice problems. Okay?